First and foremost, I would like to thank our Department of Physics and Dr. C.P. Khatiwada sir of Namchi Government College and Sikkim University to provide me such a huge platform to make a video on partial fulfillment of BSc Honours on Physics 5th semester June to December 2020. This topic carries 25 marks instead of 25 marks practical uh, examinations or sessional B. So, welcome to our YouTube channel Physics Practical Namchi Government College 5th semester. My name is Manikumar Pradhan and my roll number is 18NS0006 and my topic is Clausius Mossoti equations for dielectric, and my topic begins like this. Now let's start our topic, Clausius Mossoti relation for dielectric. Basically, this relation for dielectric was named after two scientists, Ottavino Fabrizio Mossotti and Rudolf Julius Emanuel Clausius. So here is some brief about these two scientists. Firstly, we go for Mossotti. Mossotti was an Italian physicist and mathematician from Italy. He has exiled from his liberal ideas during the First Italian War of Independence. He led a battalion of students, part of delegation from Grand Duchy of Tuscany. So he completed his studies at University of Pavia in 1811 at the age of 20. So he later taught astronomy and physics at the University of Buenos Aires. His name is associated with the multiple element lens correcting spherical aberrations and coma, but not chromatic aberrations. So you can see a brief about Mossotti. So we go towards Clausius. Clausius was a German physicist and mathematician, and is considered one of the central founder of science of thermodynamics by his restatement of Sadi-Carnot's principle known as Carnot cycle. Now, he gave the theory of heat a thorough and sounder basis. His most important paper on the moving force of heat, published in 1850, first stated the basic ideas of second law of thermodynamics. In 1865, he introduced the concept of entropy. In 1870, he introduced the viral theorem, which applied to heat. Now let's discuss about brief about Clausius-Mossoti equation. In physics, the Clausius-Mossoti relation connects the relative permittivity epsilon r of a dielectric to the polarizability alpha of the atoms or molecules constituting the dielectric. The relative permittivity is a bulk microscopic property and polarizability is a microscopic property of matter. Hence, the relation bridges the gap between a directly observable microscopic property with a microscopic property. So, the Clausius-Mossoti equation means nothing but it gives the relation between permittivity of some medium with dielectric and the polarizability. Means it gives the relation between epsilon r and alpha. So by the calculation we will do later. Clausius-Mossoti equation for dielectric matter constituting of atoms or molecules, which is non-polar molecules, is expressed as epsilon r minus 1 divided by epsilon r plus 2 equals to n alpha 3 epsilon naught, where epsilon naught means electric constant. It's a permittivity of vacuum, means some medium, and n means number density of a atoms or molecules per volume. So where epsilon r means the dielectric constant and n means, already we discussed, number density of atoms or molecules per volume, and alpha means polarizability. Basically, in Clausius-Mossoti equation, we just need the relation of epsilon r minus 1 divided by epsilon r plus 2. Moving towards the derivation part, we have some basic definitions used for this derivation of Clausius-Mossoti equations for dielectric. So firstly we need dielectric constant. Dielectric constant is denoted by epsilon r. This dielectric constant is used to determine the material characteristics of a material, or it can also define as the ratio of permittivity of some medium to the permittivity of free space. That means it is firstly we denoted dielectric constant by ER, and it's a ratio between permittivity of some medium epsilon to the permittivity of free space. Epsilon naught means denotes the permittivity of free space. So it is it has no unit, or it is dimensionless. Secondly, we used polarization. Polarization means nothing but it is the process of producing electric dipole which are oriented along the field direction, which is called polarization, or in vector term it can also define as the dipole moment per unit volume. So here what is polarization means, let's take a non-polar molecule which has positive and negative sign. So if we put external electric field, it will displace, or it will separate it. These charges will get separated with some distance, some small distance, and this will produce a dipole moment. So this will produce a dipole moment. So this process of separating charges and to produce a dipole moment, this process of producing a dipole moment which are oriented along the field direction, is called polarization. So in vector term it can denoted by p vector equals to mu by v. Mu means nothing but it's a dipole moment. V means a volume per unit. V means a volume per unit area, or per unit volume. So if the number of molecules per unit volume is n and each has dipole moment mu, then polarization can also be expressed as p vector equals to n mu vector. Means it's nothing but if we have n number of molecules, per unit volume, means in place of v we can use n, right? And in place of v we can use n. So which and each has dipole moment mu, then polarization can be written as p vector equals to n mu vector. Thirdly, basic definitions used for the derivation part is local field or internal field. It's denoted by EI or EL. The electric field which is responsible for polarizing a molecule of dielectric is called molecular field. Means electric field which is responsible for polarizing means producing electric dipole oriented along the field direction, right? So polarizing a molecule of dielectric is called molecular field. In dielectric solid, the atoms and molecules experience not only the external applied field but also the electric field produced by the induced charges and the dipole inside the dielectric. So when dielectric in solids, the atoms and molecules experience not only external applied field, means it will not experience only external applied field but also the electric field produced by induced charges. Means this is the charges and it will get induced because के हुन्छ भन्देखि भित्र र बाहिरकोले प्रेसराइज गरेर इन्ड्युस्ड हुन्छ, र चाहिँ सानो बनाइन्छ, इन्ड्युस्ड हुन्छ. सो induced charges and dipole inside the dielectric. The resultant electric field acting on the atoms or molecule of dielectric substance is called local field. Means the resultant electric field, which this field produces induced charges and dipole inside. Induced charges means applied, but also the electric field produced by induced charges, means that resultant electric field produced by induced charges and dipole inside the dielectric, means dielectric. This is acting on the molecules of atoms or molecules of dielectric substance, which is called local field. It's here some small diagram which we can just discuss this above result. So E means nothing but it's external applied field. So it can be calculated by using Gauss law. Means it can simply calculated by using Gauss law. And local field EI can be expressed as EI equals to E plus P by 3 epsilon naught. Epsilon naught means this is nothing but it's a formula for local field, or we can say simply internal field. In next part, there is last basic definitions for usable derivation, which is called polarizability, which is denoted by alpha. It's nothing but when an electric field is applied to a solid charges which are displaced, causing polarization in it, the induced dipole of moment mu vector are proportional to the local field. Polarizability means nothing but it's an electric field which applied to a solid charges. It's an electric field which applied to a solid charges displaced, causing polarization. Polarization means nothing but it is a process of producing electric dipole, right? It's a process of producing electric dipole. So the induced dipole moment are proportional to the local field, means in another form we can say that induced dipole moment means mu vector. Induced dipole moment means mu vector. Dipole moment can be expressed by mu, and which is proportional to the local electric field, local or internal internal electric field. So it is denoted by ei. So it is directly proportional to the ei. So we can write mu equals to alpha ei. Alpha means nothing but it is a proportionality constant, right? So polarizability is nothing but is an electric field which is applied to a solid charges displaced, causing polarization in it. The induced dipole moment mu vector are proportional to the local field. This is so big. So if all the atoms have same polarizability, means all the atoms which is constituent which is present in the dielectric have same polarizability, then there is n number of atoms per unit volume. There is n number of atoms per unit volume. We also discuss above in polarization. So the polarizability can be expressed as, so in next form, polarizability also can be expressed in terms of polarization is P equals to mu n, which is if there is n number of atoms per unit volume, so polarization can be written as n mu, means P polarization can be written as m mu, n mu. So in terms of polarization, polarizability can also be, in terms of polarization, polarizability also can be expressed as P equals to, which is n means n, and mu means and mu means alpha into ei, means n means number of atoms per unit volume, number of atoms per unit volume, alpha means polarizability, and ei means local field or internal field. So now moving towards the last part of actual derivations. Here's the derivations for Clausius Mossoti equation. First we derive the Clausius Mossoti equations and for dielectric constant. So basically we discussed in above that already we discussed that Clausius Mossoti generally it gives a relation between dielectric constant, which is epsilon r of a dielectric, and polarizability of a medium, means alpha. It basically gives the relation between epsilon r and alpha, dielectric constant and polarizability, right? So let's consider an external dielectric medium which is placed in an electric field. Then if all atoms have same polarizability, so and if there is n number of atoms per unit volume, then the polarization vector can be written as P is equals to n alpha ei. We already discussed in the polarizability that we consider the elemental dielectric medium which is placed, and we applied electric field in it. So here is some molecules with both the charges. See, we consider the medium, dielectric medium. Inside it we applied electric field. We considered some atoms or molecules inside in it. If the polarizability, if these all atoms have same polarizability. Polarizability means nothing but it is a electric field applied to a solid charges, which cause the displacement, which cause the polarization. So if we applied a electric field which cause the polarization, by causing polarization it will produce a electric dipole, right? So if there is n number of atoms per unit volume, then the polarization P can be written as, we already discussed that, n alpha ei, which is nothing but P is a polarization, right? And n means number of atoms per unit volume, right? So alpha means nothing but polarizability. So we know that the local field or internal field ei can be expressed as I equals to E plus P by 3 epsilon naught. So we already discussed this in the definition part, that it can also be calculated, this expression can calculate it by using Gauss law. So let it be equation 2. So putting the value of ei in equation 1, so equation 1 is P is equals to n alpha ei, or P equals to, putting this equation n alpha into E plus P by 3 epsilon naught. So P is equals to, we simplify this plus n alpha E plus n alpha P by 3 epsilon naught. So n alpha E plus n alpha P by 3 epsilon naught. So we just bring like terms in LHS. So P minus n alpha P by 3 epsilon naught equals to n alpha E. So P, we just bring out common, P, and P, if we bring out P, so it's remain 1 minus n alpha 3 by n alpha by 3 epsilon naught equals to n alpha E, or P is equals to n alpha E all divided by 1 minus n alpha by 3 epsilon naught. So it's let it be equation 3. Now we know that the dipole moment for free space relative to the magnetic moment and dielectric constant can be written as P is equals to epsilon naught into epsilon r minus 1 E. Means we know that the dipole moment for the free space relative to the magnetic moment and dielectric constant can be written as P is equals to epsilon naught epsilon r minus 1 E. This is the expression for the dipole moment for free space, and it can also be derived from the relation of D, E and P. It's nothing but D means displacement vector, E means electric field, and P means polarization, right? We can also derive this P is equals to epsilon naught epsilon r minus 1 E. This expression can also be derived from this relation. So let it be equation 4. So now equating equation 3 and 4. Equation 3 means P is equals to n alpha all divided by 1 minus n alpha by 3 epsilon naught, and here P is equals to 3 epsilon naught epsilon r minus 1 into E. Equating equation 3 and equation 4, we get, by equating epsilon naught epsilon r minus 1 whole E is equals to n alpha E by whole divided 1 minus n alpha by 3 epsilon naught. Means in LHS, in RHS, in numerator side we have E and E, so it can be cancelled out. So epsilon naught epsilon r minus 1 is equals to n alpha whole divided by 1 minus n alpha 3 epsilon naught, or So we just cross multiplied. So here this term 1 minus n alpha by 3 epsilon naught, here it comes in LHS. So in those terms which already in LHS will go in RHS side. So n alpha all divided by epsilon naught epsilon r minus 1. Now we just simplify this term. We just bring like terms in one side and unlike terms in another side. So we just simplify n alpha 3 n alpha all divided by epsilon naught epsilon r minus 1 plus n alpha by 3 epsilon naught equals to r. We just bring n alpha by 3 epsilon naught in RHS and we left 1 in that side, means which 1 already is here. So for the simplifying n alpha by 3 epsilon naught, we just take common and remaining 3 by epsilon epsilon r minus 1 plus 1 is equals to 1. So n alpha by 3 epsilon naught we just simplify, which is inside the bracket. So er minus 1 is in denominator and it's a, so by simplifying these 3 is as it is and it's multiplied by 1 into epsilon r minus 1 is as it is epsilon r minus 1. So by this doing this, n alpha by 3 epsilon naught into epsilon r plus 2 by epsilon r minus 1 is equals to 1. So already we discussed that the basic aim of Clausius Mossoti relation is to find out the relations of epsilon r minus 1 whole divided by epsilon r plus 2. Now therefore we obtain the Clausius Mossoti equation, which is shown here. Epsilon r minus 1 whole divided by epsilon r plus 2 is equals to n alpha by 3 epsilon naught. It is a Clausius Mossoti equations. For now, for dielectric, it's not for dielectric, it's also for dielectric constant also, means er means dielectric constant, right? So using this equation 5, we just denoted this above obtained equation, Clausius Mossoti equation, as a equation number 5. So using equation number 5, in equation number 5 we had obtained that er minus 1 by er plus 2 equals to n alpha by 3 epsilon naught, means er means a dielectric constant, er means dielectric constant, n means in number of atoms per unit volume, alpha means polarizability, epsilon naught means it's a permittivity of some medium, right? So by using these equations, in denominator we have 3 epsilon naught, we just bring out in, we just do cross multiplication, so 3 epsilon naught by whole into epsilon r minus 1 is equals to n alpha, which is in epsilon r plus 2 is in denominator in LHS, so we bring out in numerator in RHS. So n alpha into epsilon r plus 2. So by simplifying these, here we have 3 epsilon naught epsilon r minus 1 is equals to n alpha whole into epsilon r plus 2. So by simplifying this, we get 3 alpha, mean 3 epsilon naught epsilon r minus 3 epsilon naught, mean this, and again in RHS side we just get epsilon r n alpha plus 2 n alpha. So and like terms we bring in one side and another like term we just get in another side. So 3 epsilon naught epsilon r minus epsilon r n alpha is equals to 2 n alpha plus 3 epsilon naught. So we just bring epsilon naught in one side, which consists of epsilon r means dielectric constant, those terms which consist of epsilon r dielectric constant, we just bring in one side and take a common. So by taking common, ER equals to, means dielectric constant can be dielectric ER equals to epsilon R is whole divided by 3 epsilon naught minus n alpha is equals to n alpha plus 3 epsilon naught. So or epsilon R is equals to 2 n alpha plus 3 epsilon naught, which whole divided by 3 epsilon naught minus n alpha, means ER is equals to this, and this is in LHS numerator, which it can be equating by this equating, which can be go through in denominator. So now dividing this whole equation means by 3 epsilon naught, means dividing throughout by 3 epsilon naught, means in RHS side only, by just we divide by 3 epsilon naught, we get this ER. Epsilon R is equals to n alpha by 3 epsilon naught plus 3 epsilon naught by 3 epsilon naught, all divided by 3 epsilon naught by 3 epsilon naught minus n alpha by 3 epsilon naught. So at last we obtain these epsilon R, means dielectric constant, is equals to 1 plus 2 by 3 n alpha by 3 epsilon naught whole divided by 1 minus n alpha 3 epsilon naught, means n means number density, n means number density of atom per unit volume, alpha means polarizability, epsilon naught means permittivity of free space. So at last we derive the derivations for Clausius Mossoti equations for dielectric, means dielectric constant. Here we get dielectric, here we get the Clausius Mossoti equations, here we get only the Clausius Mossoti equation. The basic aim of the Clausius Mossoti equation is to find out the relation of ER means nothing at means epsilon R means nothing but its dielectric constant minus 1 divided by epsilon R plus 2 is equals to n alpha by 3 epsilon naught. It's only the equations for the Clausius Mossoti, it's only the Clausius Mossoti equations, and ER is equals to 1 plus 2 by 3 n alpha by whole epsilon naught whole divided by 1 minus n alpha by 3 epsilon naught, means this is a Clausius Mossoti equations for the dielectric. It's similar, means we just derive this dielectric equations from the Clausius Mossoti equation itself. So this is the equations.